Hi everyone, so we just spent all that time figuring out how to calculate the molar mass, and remember that is adding up how much each element within a compound weighs and figuring out how much the total compound weighs. And now we're going to figure out how to use it. So once we have that molar mass of an element or a compound, we can convert between the mass of a substance, usually this is going to be in grams, to the number of moles in a substance, as well as vice versa. So we're able to do this, and we're going to use conversion factors like we have up until this point, except now our conversion factor is going to be 1 mole over the molar mass, which again is in grams, or it could be the reverse, where you have moles on top and the molar mass on the bottom, which is also in grams. So let's give this a shot. It says this tough resistant coating prevents any further corrosions. What's the mass in grams of 9.45 moles of aluminum oxide? So whenever I am approaching one of these types of problems, I want to approach it similar to how we have done problems in the past, where we are underlying what is given and circling what are we wanting to get. So right now we were given 9.45 moles of aluminum oxide, and we want to figure out how many grams that is. So our first step is going to be figuring out the molar mass of this. So the chemical formula of aluminum oxide is Al and O, and there's a 3 subscript on the outside of our O and a 2 subscript next to our aluminum. Now we have to make our chart so that we can figure out the total the total molar mass of this compound in order to figure out, to even be able to answer this question. So just like we have done before in the past where we are practicing, we're going to write the name of our element, how many atoms of each element, multiply by the molar mass, which is on our periodic table, to equal our totals, right? And then we want to add up all of those together. So let me go ahead and get that set up, and while I do that, please give this a shot on your own. Like we have done before on our worksheets, we have each element in its own column. Here on the left, we have first of all aluminum, and our second one is oxygen. Moving to our first column, you have the number of atoms, and remember that is our subscripts. Then we're going to take our multiply sign and simply drag it down. And then we find our molar mass, and this is going to be on your periodic table, so hopefully you have that out right now looking at that. Aluminum has a molar mass of 26.98 and oxygen is 16. When you take this straight across, you're going to take 2 times 26.98, and that'll give you your 53.96. And the same can be said for the oxygen. You're going to take your 3 multiplied by 16 to give you your total of 48. Now to get the total molar mass, we're going to add up this column. So whenever you add up this column, your total molar mass is 101.96 grams per mole. So now that we have that, we can actually start trying to answer our question. So we're going to be taking a couple of different ideas that we have used in the past to answer our new question. So again, let's look back and see what our question is asking. We have underlined that we have 9.45 moles of aluminum oxide, and we're trying to figure out the mass. So let's go ahead and give that a try on the next page that has a little bit of more space. Just like in our first video for chapter 10, section 1, we have written down our givens. We know where we're trying to get. Now we want to write down our conversion units. So our conversion units, remember we have our molar mass as well from what we just calculated. So our molar mass is equal to 101.96 grams per mole. So our 2 conversion units, the first one is going to take that 101.96 grams and put it over 1 mole. Our other option, or our second option, is going to do the exact opposite. It's going to flip those upside down. So instead of having grams on top, you have 1 mole of that aluminum oxide on the top, and you have 101.96 grams of aluminum oxide on the bottom. And I'm going to make sure that I am labeling as I go so that whenever we do this in our calculation, we can see exactly what is canceling out. All right, now that we have our 2 conversion factors, we're going to start with our given. And that is how you always start out. So let's start with our given, and it looks like we are given 9.45 moles of aluminum oxide. So we have 9.45 moles, again, make sure you're labeling, of aluminum oxide over 1, and that 1 doesn't mean anything, it's just a placeholder. Then we're going to put our multiply sign, draw another line. Now we want to make sure that we can cancel our moles. So in order to do that, we have to pick the correct conversion unit to cancel out those moles. All right, and remember, anything on the top of our fraction, in order to cancel, we have to put the same unit on the bottom of the fraction. So if you look at number 2 here, you have moles on top again. That wouldn't work because that's on the same line or same location of our fraction. So we can get rid of that one. Instead, we're going to go with number 1. It has moles on the bottom, and remember, that's what we're trying to cancel out. So in order to do so, in order to cancel those moles on top, we're going to use conversion unit number 1. And I'm going to copy exactly what we've already written and put it on our new line. So 101.96 grams of Al2O3 and over 1 mole of Al2O3. All right, so let's double check to make sure our units cancel. So we have moles of Al2O3 on top, and we also have that on the bottom. And remember, if you have the same units on top as you do on the bottom of a fraction, those are going to cancel out for you. And that's going to give you your answer. If you multiply straight across and divide by anything that's on your bottom, you're going to get the correct answer. So whenever you do so, you're going to get the answer of 163 grams of aluminum oxide. And you can see we have included our units in our answer so that we all know that we're talking about grams now instead of moles. So here is your final answer. Let's give another one a shot. Remember, we want to start by underlining what is given and circling what our whole idea is about. Where are we trying to get to? So right now it says how many moles of iron 3 oxide are contained in 92.2 grams of pure iron oxide. So it looks like our only number that is given to us is how many grams of pure iron oxide we are given. And we are looking for how many moles. So once again, we're going to need the molar mass, and we need to set up our chart once again. Have our very familiar chart back out. We have the elements on the left, and if you look at our compound, you have 2 elements. You have iron, Fe, and oxygen. That's the capital O. Then you want to figure out how many of each, and remember that's our subscript. So you have 2 irons and 3 oxygens. Dropping down our multiply sign, now you want to put in your molar masses. Looking at your periodic table, you can find that iron is 55.85 and oxygen has a molar mass of 16. Dragging down our equal sign, now you will start to multiply straight across. So you will take 2 times 55.85 and get your total on the right, as well as 3 times 16 to get your second total. So go ahead and give that a shot now. Put these numbers in our calculator. I got 111.7 for how much our iron is, and I got 48 for how much our oxygen is weighing in this compound. Added them up together, and I got a total of 159.70 grams per mole. So now let's try and actually answer our question of how many moles we have of our iron oxide. So I'm going to copy our givens, and we're going to try this on another slide. That we have our givens written out, our molar mass we have calculated, and we know that we're trying to get to moles of FeO3, you want to start by writing your conversion factors. So our first conversion factor would be the 159.70 grams over 1 mole. And don't forget to label what it's called, Fe2O3. That's our iron oxide. Or our second option can be 1 mole of Fe2O3 over our molar mass. Oops. Now, it doesn't matter which one you write down first. You can write down the first version or the second version as your first conversion factor, but you do need to make sure that you include both. So make sure that you are able to write both conversion factors. Now, we will start once again by answering our questions, starting with our given. So the given in this example is our 92.92 grams of iron oxide. So that's what we're going to start with now. 92.2 grams of Fe2O3 over 1. Once again, this number 1 is simply a placeholder. We want to make sure that everything is lined up very nice and neat. Now we're going to multiply, and we got to figure out what to put on this line. Remember, we're trying to get grams to cancel. So we want to find our conversion factor that has grams on the bottom. So if you take a look at number 1, grams is on top. That's not going to help us cancel it out because you have to have the same unit on the bottom. So go ahead and cross that one out. It must be our second one that we came up with this time because we have grams on the bottom. And once you have the same units on the top of a fraction as you do on the bottom, that will allow you to cancel it out. So I'm going to copy it exactly like how we've already written it and figured out. And you can see now that grams is on the top. It's going to cancel out the grams that is on the bottom. And we're going to be left with the same unit that we are looking for in our goal. So now we can multiply straight across and divide by the stuff that's on the bottom. You can also rewrite it so that you have your product of the top portion of your fractions divided by the bottom portion of your fractions. So it would look a little something like this, to help you see how that works. And then you would divide that in your calculator. And when you do, you'd get the number 577 moles of Fe2O3. Mind you, I remembered to put down those units. That is going to count for a lot of your points on your tests and quizzes, so make sure that you are writing your units down. It's another good way to check to make sure that you have made it to the right goal. If your units do not match, there may have been some sort of miscalculation. Well, that's it for me today, and I will see you tomorrow.